Fuck, I forgot it was muted. So yeah, there's a little bit of a different format going on here. So I'm not sure how this is gonna pan out. Just to answer your question, no, I'm not gonna do an IED stream. You could just take what I do on my streams and do your own IED. Don't try to pin it on me, because that's how you end up going to jail, you know? Don't really feel like doing too much of that. So anyways, enough of that. Let's get on with what we will do, right? Yeah, so this, oh boy, look at that. Now with 100% less vibration because it's not connected to the table, the camera. Well, you look at this. This is my mouse. I'm kind of low on space here. I'm not gonna lie, because I got all of my soldering stuff on the desk. We got quite a few things to get through today, too. Well, I mean, besides, you know, just the usual, just talking. So I guess, yeah, let's get started. First order of business, gotta make some terminals for this, which may seem like a really, well, which may seem like really just basic work, and you'd be right, not gonna lie, but you know, it's also important. You can't just it's all part of the fun, isn't it? So, well, let's get it going. I got a pretty nice, pretty big, nice piece of wire. Because we're gonna need it. I'm gonna try to actually put it all, like, put it all on, since now I have the space, I'm gonna try to, well, you know, show more of what I'm doing. Kind of dark in here too. There we go, much better. But damn, this really doesn't want to strip. All right. Now, I think we can use my bad solder for this. Yeah, I think that's gonna be it for now, at least. The wick. My lineup of soldering equipment. Not gonna use the stacky flux now, but you know. Anyway. So this got soldered into the tip. It's oh yeah, I forgot that the dried cam doesn't do autofocus. Hold on a second. Because this has two connectors, one right here in the middle. This focusing is garbage. And then there's the ring connector, which is the big one. But yeah, so got onto that. Kind of a challenge actually. Fuck it, I'll just okay, doesn't seem like it's too loud. At least OBS isn't picking it up, so not sure if it's because let's see. Trim some of this off. Wet this a little bit with flux. Should be enough. Because either way, the 330 degrees sounds good. Oh yeah, maybe I should wet the maybe I should wet the iron with my actual proper solder. This is the good stuff. I can barely even see it. Maybe I should zoom it in a little bit. Yeah, it's still got me up a little bit. That's why you need to take care of your tips, guys. Yeah, I think this could work. I really could use an auto feeder, to be honest. But this will have to do. All right. This isn't. Need to be careful now. It doesn't seem like there's a lot of solder parts to stick. Okay, hold on. No, it's just balling up. It's not hard enough. Yeah, I'm really gonna have to put to stick solder in this. Wait for it to get to temperature. Let's go. Let's go. Okay, I think this should be okay. Let me check real quick. Oh yeah, this is definitely cold. It's just doing solder balls. But oh well. We're gonna try it anyway. Or maybe it just needs some more flux. That's a lot of thermal mass. Jesus Christ. I can feel it starting to soften, but... Oh, there we go, there we go, there we go. Okay. Oh shit, I took it out too early. I feel like it's actually synced. Ah, fuck. Hold on, hold on, hold on. What? Shit, that's hot. No way. It melts through the plastic. Oh my god. How horrifying. Man, we're really in the shit now. Tonight, maybe. Straighten it up. Maybe if I heat it up and yeah, don't try this at home. I'm just doing, just trying to fix a little fuck up by maybe making an even bigger fuck up. Yeah, this just ate through the plastic shielding. Jesus Christ. Well, that was a bit... We're off to a rough start this time. Yeah. Maybe you can still salvage it. I don't know. Starting to second guess myself. I mean... We'll try. Yeah, this just eats through the insulating plastic though. The dielectric. Don't think it's gonna work. Yeah, we might have to put this on hold again. Ooh, darn. It really just ate through the plastic sheeting. What happens if I heat it up through the other side? We can get it back into position. It's starting to get hot to touch. Come on, come on, come on. Oh, fuck. I mean, that's interesting. I'm not gonna show this on camera. We should be back basically to where we started at. No, we're not. Using tools for their not so intended purpose, but so whenever yeah, I need to bury this in somehow now. Remelt the plastic again. Oh jeez, this is gonna suck. Maybe just enough, because I kind of well, I'm at it. Might as well see if I can get this to stick. Yeah, because there's just a lot of thermal mass in this thing. And the solder doesn't really want to stick. Let's try something. It looks like it's back on the plastic though, which is a good sign. I mean, it just means we're back to where we began, basically. I'm gonna try to basically make this anchor this down first. That way I don't need to be holding it. Alright. This... Nah, still don't trust it too much. Well, full disclosure, this is actually the first time I actually solder one of these jacks. So, yeah. So, I'm well aware that I might just be doing something wrong. Okay. This will work. Now I have a sort of why didn't I think of this before? That way I can just hold on to the solder. Let's try this. Oh, I'm starting to second guess myself. Fuck it, I'll get some flux. Probably gonna be better. I think I've gotten some paper towels too, because this can get a little bit messy, but I guess I'll clean it up later. Come on, everyone, time to get your shots! Oh, Jesus Christ, this is tight. There we go. Oof. There we go. Inject a moderate amount of, well, I'm not injecting anything, just placing it with a syringe. Moderate amount of flux. Probably too much, but I don't want to risk it. Now. The solder is sticking, but not the fucking wire. Gee, bus. Imagine that. Okay, I think I may have gotten a lag in now. There we go. Not too Oh my god. I can't believe it. At least now we got a pretty nice solder ball where we can just, well, try to do something with it. Hopefully not fuck it up even more. Jeebus. So not even SMD soldering was as bad as this. Yeah, it's just not sticking. Oh my god. What is going on? Alright, well, fuck it, I'll do this some other time. Probably not worth the hassle right now. Well, still, it's kind of crunchy, but okay. God damn. Probably would have been easier to just put insulating tape on it. But anyway. Next order of business. So I kind of how can I explain this? I kind of fucked up on the ordering and bought the wrong type of capacitor. So if you can see, if you saw the image, you know what I'm talking about. If you didn't, well, I'll show you right now. The slot, the pads where C7 would be are currently empty, and I don't really feel like risking the I don't feel like risking everything just for this one capacitor. So well, time to do it right now. I have it over here on my desk in the middle of everything else. Here it is. It's kind of absurd how small these things are. So, like, look at this. Just this bit of tape has 50 of them. I mean, it looks kind of big, but you know, I'm zooming in quite a lot. Anyway, we have some stuff to do. So let's get started. Kind of feeling like Louis Rossman right now, you know, doing micro soldering like this. But yeah, I guess that's probably a common feeling. You can be using this. Probably junk. Now, remember, kids, never buy cheap solder. It might say that it's made in Italy, but it's not. Apparently, but it's still garbage. Still don't have a microscope, so we're gonna have to make do with this arrangement. Hold on. Oh shit, I forgot the tip for this one. Fuck, give me a second. Luckily I caught it in time, because I can still turn it off before it gets uncomfortably hot to the touch. This is a Philips. Alright. Ah, fuck it. You know what? Just the tip. I'm gonna tighten this in so it doesn't dance everywhere. Should be good. Yeah, perfect. Alright, now I can get started again. Here we are. Let me take these out of here. Alright, just melt it into the pads for now. Add in a little bit extra. Because it's better to have too much than too little, you know. At least in this line of work. Let me inspect it real quick. Yeah, there's something really fucking dirty in my stuff. Because I'm starting to see this black residue everywhere. It's probably the garbage solder that I bought like 3 years ago. When I was just doing when I was just starting to get into it. Ah, but where did it go? Okay, they're both the same. It's a ceramic capacitor, so the size doesn't really matter much. Now the secret is, you probably can't see that it's a little bit crooked, but yeah, you know. The secret is, with SMD soldering, at least that's what I learned, is it doesn't really matter if it's a little bit crooked or not. If once the solder really heats up, and you can't see shit now, but I'll try to correct that. Once the solder heats up, it's just gonna conform into place. I think this should be okay. I'll take it off. Not a very good idea to just take it off immediately after applying heat. This looks good. Let me see. Yeah, that's in there. This too. Didn't mess too much with that other one. Alright, great. Now, since this is a very delicate area, probably a good idea to, you know, just sanity check that probably a good idea to just sanity check that it's all that it's just not bridging. So you should be seeing a open line here, yeah. Perfect. Is there anything between VCC and ground? Nope, not a thing. Alright, we're good. Now, I would really need a lot thinner, a lot finer tips to analyze the actual microcontroller, if everything's in place. But I'm just gonna go on a limb and just from visually inspecting it, say that everything is okay. I don't see any other way of actually doing an inspection in this, at least not right now. Anyway, now we just need to solder in the headers, and where's my big bag of headers? Oh fuck, here they are. Alright. We're gonna have to solder the headers in. Ba-ba-da-ba. Ba-ba-ba-ba. Ba-ba-ba-ba-ba-da-da. There we go. So we got 5 of them, if I recall correctly. Yeah, 1, 2, 3, 4, 5. Space exactly the 5. There we go. That's what we're going to be using now. It fits like a glove. Look at this. Should probably zoom in. Really need to find a better way to do this. But yeah, almost no sag at all. Look at this. Still need to solder it in though. So give me a second. Is that max zoom? Yeah, I'll always liquefy it a little bit before actually going in with the iron. Just makes it a lot easier to pour. Just makes it a lot more manageable. I've probably preheated the board a little bit too, but kind of just went into it. Okay, you know what? I'm gonna preheat the board. Otherwise, we're gonna be here for an eternity. Alright, you know it's good when it starts smoking. Where the fuck is all the smoke coming from anyway? Ah, fuck. Yeah, that's probably not a very good all the plastic is really melty today for some reason. Which is kind of weird, because if the code, it should actually be harder to heat up stuff. And the only hot things here are really the irons. Alright. Alright, looks good. SDA is looking kind of empty. Yeah, you can actually see it through the video too. They look okay. Nothing to be really proud of, but good enough. As long as it sticks to the board. And I guess I found the source of the smoke from earlier. It's from it's from the plastic underneath it that burnt, that got a little bit melty. All right, should be using lens pretty close, but that's what I got. There's not that much here, and I'll still give it a little bit of a whack. Should be using a lens-free cloth for this, but don't have any lying around. Oh yeah, that looks a lot shinier. Oh jeez. Because with this done, we should be ready to just put the sticker in place, which is actually a necessary part, since the solder is conductive. The HASL cover is conductive. Oh yeah, now it looks clean. Oh damn. Hot damn. Where is it? Find the stickers for this, that would be great. Could be in here. Oh, they could, but they aren't. Well, back to looking. Oh, hold on. No, there's a free eight. Jesus Christ, where are the stickers? Oh, here they are. Now, which one should we use? Now, we'll use the directional one, which is, well, I'd say more true to the testing function. But it can still be decided later. Probably be using an X-Acto knife for this too, but don't have the cutting surface for it. Also, it's circular, so an X-Acto knife isn't exactly gonna be the best option, is it? There we go. So, oh yeah, that's perfect. Perfect fit. So I guess I'm gonna be working on this exclusively today. Maybe I should have given it some slack. I do not know. Can I try? Can I give it another try? Yeah, it doesn't seem to be glued in that strongly. Because I think I really gave it some really tight margins here. Yeah, I tried to fix one side and the other, just good enough, I think. It's also not that centered, but still a prototype. Now, I'll get a small PCB. Oh, there's just one thing I want to check. Oh, something's wrong. Yeah, I'm gonna need some support from the... Jeez. Yeah, they should really invest in some, God, look at the sag on this thing. This isn't my fault even, it's just that, Jesus Christ, the holes are huge. There's really no, oh, damn. Gonna make a small support from this piece of scrap paper. See if it works well enough. God. Oh, it just go. Oh my God, it even sags sideways. Yeah, there's fucking rotation in this thing. Is it just this one, or are my other ones also this bad? I think I can... Oh no, all of them aren't like this apparently. Ah, damn. Let me see this one. How bad it is. Oh. Oh, there's sag. A lot less, but still. I guess we're gonna just be using this one and really tying it down. Let's see. So I'm wondering if I can use the electrical tape to sort of tie it down somehow. Let's see. Kind of a bit, I'm gonna try a bit of an experiment here. We should give it enough thickness, but I think it's still gonna sag a little bit because the electrical tape isn't that tight either. Probably gonna sag a lot less though. Oh no, this actually works pretty damn nice. Oh jeez. So I really just need it for it to is it interfering with anything on the board? Hold on. I should move the electrical tape a little bit this way. Yeah. This actually worked pretty better than I expected. Yeah, this is gonna be my testing setup, unfortunately. Oh yeah, this is great. No interference either. So kind of just glued it here. I mean, if it works, it works. Means I can put this thing away. I think we can put yeah, I think you can put everything else away too, and go back to and return to the code. Since it's cold, might as well be cold. How cold is the code? Oh, it's been a while since I've messed with it, so probably very cold. No, I will not stop making puns. God, this noise is driving me a bit crazy. the fume extractor. I mean, it's important, but just too damn loud for it to be here in my right beside my head. Anyway, that's there's still one thing here. That should be more or less everything. Okay. Oh, finally some fucking peace. Yeah, I'll leave this on here on the table. I mean, we can do a little comparison here, version 1 and version 2. Looks more or less the same. That's kind of on purpose, I think. But paper trash. That's on purpose mostly because, you know, why would you change from one version to the other so much? But well, it is what it is, isn't it? I'll leave this here for troubleshooting. Take this wire out. Just occupy my desk real quick so I can actually have some room. Alright, I'm back. Alright, I'll just leave this, take this one out. We're testing this one, since that's the, that's the new version. Now with I squared C. Now with I squared C and, well, all built-in capacitors. Just because. More reliability. Now, why don't we get Eclipse going? And here we go, touch wheel. Let me get the cam going. Right, I was programming the JTAG to UPDI. It's basically, you program it onto a nano, and you can then program 80 tiny controllers with it. Pretty neat stuff, I'm gonna say. Thing is, I'm gonna set the, I'm already gonna set the programmer. Where the fuck is it? Board at MVG, what the fuck? Okay, we kind of have a bit of a... Oh, Mega Tiny Core. It's an ATtiny 817. Where is it? 817, here we go. I already set up the compiler beforehand because that's what we're going to be using. 817, save EEPROM retained. Oh no, it needs a bootloader, so no set, don't retain. I will use the 10 megahertz internal clock. Oh, the internal clock on 10 megahertz. Because if I recall correctly, that was the default time for where's the voltage? Watchdog timer. Timeout disabled, printf default. Minimal because I'm not really going to be using printf. Oh, here we go. Yeah, I want the brownout voltage to be 2.6 volts. So we can even use it if it's 3.3. I think that would be the optimal choice, really. I have to do some testing on this later. Startup time, 0 milliseconds. I want it to start immediately. Maybe I'll put a few 8 milliseconds. UPDI, no reset. I'm still not sure if I want to do it, so with reset. Oh no, wait, it's UPDI, no reset pin. The other one is only for 2 series. Brownout detection mode. When active, sleeping. Burn bootloader required. Enabled. Attach interrupt on all pins. Millis micros, I'm gonna use the TCA 0. Oh, apparently the millis and micros will use TCD 0 on 1 series, so I guess I'll use that. Watchdog timer window. No delay before window opens. Alright. And still don't know what the port I'm gonna use, but indexing. Alright, so I'm gonna have to create a new file actually. Yeah, I'm gonna have to create a new file that's gonna be built. So touchwheel.h, it's basically gonna be the same thing. So new, well, header file. Touchwheel, this is the 8 on 7. Header file, touchwheel. .817. Folder touchwheel 817 doesn't exist. I'll just name it touchwheel then. File name is discouraged. File extensions not correspond to known header file types. Oh, .h. There we go. Default C++ header template. And I also need to create the C file, the new source file. Material 817.cpp. There we go. Honestly, it might not even be that much different from when I do the H271, if I'm gonna actually even do it. I had it on plan to use that one, but you know. Oh, we can start porting the code then. Version, well, for now we'll call it 0.1. Or this is the ATN 817. I think I'll take out this disclaimer and then rewrite a new one. But for now it's just this, then I gotta add some details later. If and def define and if. Okay, so wait, the header. Yeah, same thing here. .1 ATN 817. Because it's still a very pre-production, not gonna lie. So include first things first. I think it was included. Oh, IRA tutorial stream. I mean, if you want to, I don't really recommend using this to make weapons, but I mean, if you fancy it, go ahead. I'm not gonna stop you. Would be probably a very bad way to make a weapon. Actually, this like very bad interface for the weapon. It's if I recall correctly. Okay, yeah, it's gotta be. It's case sensitive. H. And yeah, I'm not gonna be able to use the I'm not gonna be able to use the Arduino library for this one, I think. Well, I'll just include it anyway, just in case there's something I need. Alright. So, yeah, first define everything. The trio ports. I should have what does touch wheel ports refer to? Ah, touch wheel ports, port either set. Could not be resolved. Oh, probably because this board doesn't have port E. Port E.outset, enable output port for touch wheel. Why 0. Why 0x0f? I will have to take a look at the documentation. If you give me a moment. I might even be able to show it here. The data sheets. Where are the data sheets? Data sheets. That's 80 tiny for. I'm gonna have to download it. Download datasheet. Here it is. Yeah, this will do. So, hopefully this is the complete one. IO multiplexing. I also have to open a circuit maker because I gotta get the reference for the design. To see which board I actually used, I should have a schematic here though. This is the wrong schematic. I don't think I printed this one. Oh no, I did not. I see, you should always have a physical copy of your schematics, just in case. But if I recall correctly, if I recall correctly, all right, there we go. It was port E. No, port E. There is no port E. I think it was port B or D. Let's check real quick. All right, so for the touch wheel, port C. Okay. Which means touch wheel ports. They're set. All right, so I'm gonna have to go to the PITWI, a analog comparator. And I realized too late that I could just use the port. That there was an actual function for this that does exactly what I'm doing. Realized it a little bit too late, but yeah. Here out goes to the pin, in is on the synchronizer. All right. I really want to know they're set. Data direction set. Oh, okay. So it just sets the entire port to yeah, it just sets the entire port to output. Which I guess, do I use no. It's just C0 through PC4 that I actually need. But I guess if I put the entire port, it doesn't really make much of a difference, does it? Because we even have a PC, okay, so PC0 through PC5 would be the SPI port. Yeah, no, that's it. So I can just do 0xF. It's basically going to be a very big copy and paste. Very big copy and paste job. Void setup, right. Like, it's not even funny. So this is gonna be port C. And you're also gonna need a toggle interrupt. Did I have any comments on it? No. I mean, it's self-explanatory, so I probably don't need to. But yeah, it's just a matter of copy-pasting and enable mux selector ports. Mux port was 0x07. Zero point zero zero x 07. Well, what was the mux used for? Oh, right, the mux. The 4051. CD 4051. Let me just make sure. PC results to measure time array. If port.out unint unless port.out unless port. Okay, yeah. First port, first mux. Right. Oh, so the mux in our case is on S0, S1, and S2. So PA5, 6, and 7. So 5, 6, and 7, that is gonna be 1, 0, 0, 0, 0. 0, 1, 2, 3, 4, 5, 6, 7. Oh no, wait, this is decimal. It is an E0, okay. Yeah, see, it's just, but then I can just 0x E0. A lot of magic numbers. You know, things that actually need to, I don't like that this is 0x0f, though. Because F just, I mean, I guess it doesn't really make much of a difference, since I'm not going to be using all of them. But, because F is just going to be... I don't want octo. It's just going to be basically the entire... Oh, wait, 1, 2, 3, 4. Oh, no, wait, so I need 5, so it's 1F. Since it's, I think PC0 through PC5. Yeah, PC0 through PC4. Since this one has the middle button too. Okay. Mux ports. ADC ports is next, I think. Anyway, let me get the next line. Right, I need to find on the schematic, where is the ADC tied to? Common PA1. Okay. PA1. Thing is P1, pin 1 control. Let me just make sure of that. Right, datasheet. So PA1 is AN1, okay. Yeah, it's also UseArt and 2i. I'm gonna need to see the port mux for these. Although I think... Oh no, alternate. Yeah, I'll have to check the port mux for to see these Mizo Mosey. Alright, yeah, that's it. I want to check for pin 1 control. It's pin 1 in it. Or Sport Mux. Sport Mux. No, not Port Mux. Just Port. Instruction set summary, useart, TCA, BOD, port. Oh yeah, pin 1 control, pin 0, pin 1. So yeah. Basically the same thing as the 4809. I don't think there was a very significant change in the instruction set. Buffer on, I'm gonna just have to change some of the references. Enable ADC with 10-bit resolution, enable low capacitance mode, VDD reference, and 256x prescaler. Alright, I'm gonna have to go on the ADC part of the datasheet. Where is ADC? ADC here. Okay, Control A is NBC with 10-bit resolution. 0x81 is gonna be then run standby. Let me check. X 81 10000 and 0001. Okay, yeah, so ADC enabled, 10-bit resolution, and run on standby. Okay. That's fine by me. Then Control B was the other one, next one. Control C. Control B is just a number of samples. I don't want to accumulate, so it's just 0. Enable low capacitance mode, 256x prescaler. It defines the division factor from the peripheral clock to the ADC. Okay. Reference selection. Voltage reference for the ADC. I think it was internal. VDD reference, yeah. And 256 prescaler. Why did I do this? I don't actually remember why I did this. Why did I do the ADC? Wait for ADC results to be ready. Wait ADC results to output measured time array. I actually don't remember why I put the 256 prescaler. Well, whatever. So, well, I just leave it like that. ADC mux pause is 0x03. I want 0x01. That should be it for this part. Next, I'm not going to include serial debugging for a very good reason, because well, simply put, I don't have any serial ports. Now I squared C. Oh damn. So, which port did I use for I squared C? I squared C, it was port PB0 and PB1, okay. Port PBZ, port B, port B, port B, it's pin 1 and it's pin 0 and pin 1. I think I think this was just to set to leave the port open, if I recall correctly. I'll check it right now. Analog I/O, peripheral override. I want to check, because I'm pretty sure TWI doesn't use the same. It gets connected to the port. Anyway, IO multiplexing. Let me check. It's PB. PB0 is the default apparently. Yeah. If I go on port mux. TWI 0. Here we go. Control B. This bit selects alternative communication pins for TWI 0, which would be. Is there any other explanation? No, it just goes straight to it. Yeah. So IO multiplexing and considerations. So the default ones are PB0 and PB1. The alternative ones are PA1 and PA2. Fair enough. I did not do any port muxing. Oh, hold on. What is the pin 0 and pin 1 control? It's on the port configuration. Pin 0, inven. Input and output values are inverted. I think there was something about that. Gotta say, this is a weirdly chill stream. I mean, it sure is. It's just me. It's just basically doing you know, just the bare minimum to not just be called lazy. Anyway, so for TWI, if I recall correctly, client initialization. SDA hold time from TWI. No. I like to see the although that's probably explained in the ports. And I mean, it's not even something that's just you know, that's not really taxing. It's just you know, it's basically just copying and pasting. I'm kind of concerned with why the direction is just 0. I use any other of the B ports actually. No, port B is just exclusively for this, so great. You can leave the direction 0. Pin 0 control, pin 1 control. pull up enabled. Input sense is disabled. Yeah, I guess that's just it then for the... Was there any other configuration for the DWI? Yeah, Control A. Fast mode enabled. Address is 0.028. Data and address interrupt enabled. TWI slave enable. Is this correct? Let's see. Where's TWI? Here we go. Oh, here's a state machine. Not what we're here for, though. It's Control A, SADDR. No, not this. Okay, Control A is just 2, so yeah, just FM, FM plus. Then SADDR, which is the address. Upper 7 bits is the address, the least significant bit. Combination of general call address. Okay, yeah, no. It's Control A. Slave client Control A. I like how they can't change the name of the actual port itself. It still has the slave Control A name, but they try to change it to client Control A. We all know it's not a client, it's a slave. Anyway, what do I got here? It's a 0xC1. Data and address input enabled. Okay. TWI slave enabled. Yeah, bit 0. I don't do smart mode because it's just bad. You know, sending the acknowledges automatically. Anyway. Alright, TWI is already copied and pasted. This is all my own code, so I do not need this anymore since I'm already configuring it on the source. Oh fuck no, I do need it here. In case I actually have to use the 4809 again. Right, now it's just a bunch of flags and data, and the setup is done. So, you went 16. Am I using actually an int 16? Oh yeah, because it's do I actually need to use this? Oh well, whatever. Next up, they make the loop. Loop the loop. Now in the loop, it starts with the toggle interrupt. I need to copy that function too. And the ISR. I'll do it right now. I have anything of the interrupt? No, I don't have anything of the interrupt service request. This all has a. This is all reference to the TWI, so don't think I need to change anything here. The toggle interrupt, yeah, it's also reference to the TWI, so don't need to change anything here either. Efficient coding. Also, this TWI I could probably improve it a little bit. It's very bare bones right now. So inside the loop, what do we got? Well, toggle interrupt. Then if T flag. I'm not really sure. With this compiler, it should select automatically the millis and micros timer uses TCD0. What does TCD0 do? TCD timer counter. Well, my biggest question is, will it will millis and micros I might have to actually measure that once I write down the once I actually burn this into the microcontroller, but I really just want to make sure. Ah, fuck it, I'll check it on the tests. If not, I'm gonna have to change it. No delay here. Oh, I think the delay function is what's the Arduino exclusive. Yeah, that's probably gonna be it. So if I'm gonna have to change some because this now is port B, this port C. Wait, is it? Port E on the other one was used for... Oh yeah, touch wheel ports. And this is port A, right? No. Yeah, it was just port B. Wait, did port B remain the same? Man, I'm kinda starting to second guess myself here. So port B, outset 00, mux ports. Zero XE0, 0x07. Right, no, I'm gonna have to change the first mux to Right, it was 1111. No. The mux is 5, 6, and 7. So 111 0 0 0 0 0, there we go. So the first mux is gonna be just this bit, so one zero zero zero. Basically this. It's a 2020. Is it a 20? Oh, yeah. Yeah, now you see what I mean by second guessing myself. And the last mux are gonna have to... It's wait, is it? No, because it starts at 0, doesn't it? The first port is Y0, so it's all 0. This might actually be a little bit more complicated. Actually, no. Port A. PA4 is clear. So I could just do 0x10 and then this is a 7. 101. One zero 10 is A0, the last one. Wait, is it? Jesus Christ. Start 000. Yeah, it is A0. Because it's gonna start 1 1 0 1 1. We're gonna have okay, I'm just gonna do 0 0 then, and hold on, the mux is on port A. Mux ports, what? No, this is wrong. Port A. Port A. Did I have anything else on port A? Oh yeah, the UPDI. But I'm not really using it, so yeah, 0x00. And then the ADC was on also port A, pin 1 control. Anyway, for port C, yeah, it starts on 0 and goes to 5. 0x01 to 0x08. I think it's 0. 16, yeah. No, I want hex though. Hex this one is 10, yeah. Then first mux is gonna be 0 0. Last mux is gonna be A0 because it's gonna start with it's gonna start on 20. I was gonna start on 0, 20, 40, 50, 80, 100, no. It needs to end on 4. Fuck. Because it's going from... It's 5, 6, 7, but it's 0, 1, 2, 3, 4. Yeah. It needs to end on 4. No, hex is gonna be 80. Okay. Sounds a lot better. Three ports. I might want to do a bit mask though for port A because although I'm really not going to be touching port pin 0 at any point, so I can probably port A, not out, not plus plus, but plus equals. I need to add 0x20 every time. Yeah, because in the end, port A, their set is always going to be, well, Mux Sports is going to be E0, yeah. So then the ADC is also always going to be an input, supposedly. Yeah, hopefully I don't fuck this one up. Next. Oh, this is where I'm gonna have to. I'm gonna avoid using the delay function and just go while int for 256 2, 4, 8, 16, 32, 64, 128, 256. To write 200, I need to write 200 in decimal. How many bits do I need? Okay, 8 bits. Yeah. So I can do just a byte. Well, byte. Smaller than 200. Why is it giving me an error? Syntax error. Field, dear set could not be resolved. Oh, okay, yeah, no, never mind. Warning. Why is it giving me a syntax error? Can I not declare a byte inside the on the while loop? Bloody hell. No, I can't declare a byte at all, apparently. I'm just gonna leave it like this. Well, byte to delay. byte k is smaller than 20. All right. The 200. I want to. Oh no, I probably can't declare it here. After all, byte delay. There we go. I want to initialize it as 0. Yeah, but then less than 200. Yeah, let's just do it like this. So delay equals oh, hold on. Wait. I want to initialize it, but I just need a byte. Actually, this actually might not work because it's too small. I think I have the space to make this an int. At this point, it's delay. I think I need two variables. Insert time. Insert time equals micros. I think the micros is 32 bits. Nah, it doesn't really give me anything. Equals micros. Because I really just need a delay function, not really anything else. No, micros minus clear time. And oh god. Now and then at the end I will reset the delay. All right. Next. So delay microseconds. It should all be the same. ADC capture, then empty port B dot out. No, and you gotta change this to port A dot out. No, this isn't gonna work. Dot out. Because if I recall correctly, port A dot out was yeah, it went from first value. Port A is the mux, so last mux was 0x80. So it's basically this, so I need to shift it 5 port A dot out, shift 5 adc.0.res. Okay, shouldn't give too big of a time penalty. Then TRD goes micros minus TST. Okay, up next. If TRD bigger than 900, yeah, all this I think I can keep. Except I will take out the debugging since it already works and I don't have a serial port. Actually, take out all the serial references. Oh, byte k equals 0, k is smaller than 3k plus plus, if mtk equals ctk, curve bit equals 0ff, and 0 x01 shifted by the number k, dt equals dt, or current bit. Then TRB equals DT, DT equals 0, toggle interrupt. DT being the detection byte and TRB being the transmission byte, which we're going to transmit using TWI, hopefully. So, let's see, verify this. Oh, it's still treating it as a... It's still treating the touch wheel CPP as the main one. Might want to make another project then. Touch wheel 817. Mega tiny core. I'm gonna have to do all the configuration again. 817, where is it? 817. Can I increase this? Yeah. Upload protocol JTAG to UPDI. Still don't have the COM port. 7. 10 megahertz internal. Watchdog timer disabled. Minimal BOD 2.6. Startup time. I'll give it 8 milliseconds. UPDI. Ba, ba, ba. Finish. Now I can delete these. Drag these two in. What is going on? Oh, I don't need to include this. No, actually. Unresolved inclusion, touch wheel 817. How did I do on this one? Huh. Unresolved inclusion, touch wheel 817.h. But it's over here. Shouldn't be just because I have the... Nah, that would be too... Yeah, because all the rest seems... Huh? Byte could not be resolved. I'll have to find, include... Alright, so... Touch. Oh, okay. Yeah, that's probably what was going on. There we go. Now it's all okay, what's going on here? Define, delay. Oh, there's already a delay. Define, definition. I'll just rename it loop delay. Pointer and integer. What do you mean between pointer and integer? Oh, it's probably, yeah. Okay, yeah, it was just a problem that the delay was already being considered a pointer. Alright, it's compiled. Just fine. Now, what I really want to see is, will it program? The PS3 controller. There we go. All right. All right. Cable. Where are my colored cables? Here they are. Because what I really want to see is, will it power on? Red, gray, black, okay. Will I be able to program it well, first of all? Because I'm not even sure if I soldered it properly. And I did the dumbass thing of not putting any LEDs to indicate. Anyway. Oh yeah, this is a little bit too much zoom. Droid cam. Here it is. So here's my, well, what should be the UPDI programmer. If I recall correctly, it was VDD. Oh, maybe I should plug this out first. Gosh darn it, I forgot which one was ground. I know that the VDD is the one on top, but which one's ground is a little bit of a... Oh. Oh no, this is the... Need the... Yeah, this one's ground. This one should be... Yeah, 5 volts. And the other one's data. Good. Which means we're ready to actually test this out, because I still haven't tested out the UPDI programmer. It is gonna be it is a mystery that we're actually gonna be discovering live here. If I could just push this in. There we go. Maybe pushing 3 of them in at the same time is kind of... So I need to connect VDD to VDD. Zoom in again. VDD goes on VDD, which is this one. Ground goes on ground. Problems of really new cables is they are kind of rough around the edges. And the other one should go on URES. Let me check. I think I had it still open here somewhere. Create your own UPDI programmer. Oh boy, I will post the link to the tutorial to make your own UPDI programmer. Yeah, so this one should be wired to UPDI. Great. Now, let's plug it in. And I hope we don't see any sparks on either end. Oh boy. Here goes nothing. Alright, so far so good. Huh? What? There's something wrong with the cable, I think. No. Gosh darn it. Is there a short? Oh, I can use these. No, no shorts. Maybe on this side? It will be easier to, No shorts. What's going on? I'm gonna have to measure the voltage once I plug it in. I'll try to get some leads to wrap around it. Do I have anything here that I can wrap around the ground? I guess I could use this mangled mess. Ah, this won't work. Oh, it's staying on now. 3.5 volts. 3.5 volts? Three and a half volts out of the 5-volt line. Is that what I'm receiving here? Yeah, because I also had, there's also a 3.3 volt line. Maybe it's connected to that. Yeah, the 3.3 volt line is okay. We're giving out 3.6 volts on the program or the serial. 2.5 volts here. On this VDD though, 3.5, okay. It should be enough to program it, I think. Although I do not like that it's the voltage is so low. I'll try to disconnect it and see it by itself how much it gives out. Yeah, by itself it's giving 4.6. You can see the multimeter. .656, which means there's gonna be a. Let me check the resistance here. Three, 4 open line, 4 mega ohms. Weird. Oh well. We're gonna try to program it. There is no ground fault apparently, which is good. Well, there's no short to ground. Probably would be a better term. So. Okay, it's staying on. Let's see. Properties. So it's on COM 8, yes. Let's try to upload it. Speed. Did anything happen? Invalid baud rate specified. Did I have to select a baud rate in any place? Oh, okay. I'm guessing I may have to debug this a little bit by myself. Don't see any baud rate. Invalid baud rate specified. Well, what could that mean? Yeah, no, it's just not gonna program. Well, what can I do? Doesn't want to chooch. I may have to do some more configuration on this somehow. Unless... fucking hell. Where is it? Ports, USB serial port. Port settings, 57600 I think it was. Invalid baud rate specified. Might have to change it then. Level 5200. Program.speed. What the hell does this mean? Yeah, no, so changing the baud rate on the settings doesn't really do anything. So it's probably oh, it's building just fine. It's just, yeah, I think I'm not gonna call it then. Well, thank you very much. Thank you guys very much for watching this disappointment. This disappointment that was the end of this stream at least. Well, we finished a little bit of stuff. We ended up porting the entire code to this to work on this. Unfortunately, we didn't kind of actually get it to work, but you know how it is. We'll get there sometime, even if it costs me, I wouldn't say my life, but even if it costs me money. But yeah, thank you guys very much for watching. If you liked the stream, don't forget to subscribe, leave a like, and I guess we'll see you next time. And bye-bye.